Hi everyone, my name is Deyu Wang. In this talk, I'll introduce our paper titled Learning a Style Space for Interactive Line Drawing Synthesis from Animated 3D Models. There have been many computer graphics algorithms that generate line drawings. Computer-generated drawing approximation can be divided into non-photorealistic rendering that takes a 3D mesh model as input, and image processing that takes a 2D raster image as input. A previous analysis of how humans and computers draw showed that current computer-generated drawing approximations are not capable of representing the diverse drawing styles that people employ. Even though there are multiple NPR methods, there's no straightforward way to adjust thresholds or interpolate different methods in order to match a user-created drawing. This is one of the reasons why many artists still prefer drawing on their own over computer-generated results. Particularly in the case of animation, animators often need to draw many sketches frame by frame, even though it is a tedious process. Wouldn't it be great if we develop a method that can make line drawing animation easier while allowing user control, so we can get the best of both worlds? We envision a system that takes animated 3D models as input, and the user only needs to provide a keyframe drawing. Then, drawings at all other frames will be automatically generated in a style consistent with the user's expectation. The user should also be able to add a new keyframe drawing, and the output at all other frames will be automatically updated by propagating and interpolating the user's drawing style. Technically, we'll formulate this problem as learning a style space for user control. Here, we show a style space expanded by commonly used NPR output, including contours, suggestive contours, regions and valleys, and apparent regions. Given a user's drawing and its corresponding geometry, we want to learn a latent style descriptor so the user's drawing style can be transferred to other frames. Our goal is to create an interactive system for synthesizing line drawing animations. Given a sequence of 3D models, an animator creates drawings as some keyframes. We expect the system to learn the styles and propagate or interpolate to all other frames. The animator can then refine certain frames and iteratively edit the animation. Our approach is based on generative adversarial networks, or GANs, that have proved effective in image synthesis tasks. We use the GeoNet, which encodes the map of geometric properties MA at frame A. We also use a StyleNet, which encodes the style of a drawing IA to a latent vector Z. Then the generator can use the geometry code and the style code to generate a drawing in the same style. To train this network, we first generated a 6-channel map containing geometry space and image space features for each frame. We included the production of normal and view vectors, the depth map, and 4 types of surface curvatures used to generate commonly used non-photorealistic renderings. We then generated a synthetic NPR dataset for training. For each frame of an animated character, we combined contours, suggestive contours, ridges and valleys, apparent ridges, and canny edges using different thresholds and generated 68 NPR line drawings of distinct styles. One important property of this network is that the StyleNet should be disentangled from the GeoNet. In other words, in the lower branch, no matter if the input is frame A or frame B, as long as the drawings are the same style, the encoded latent vector Z should be the same. Therefore, we use an intrinsic loss during training to enforce this property. We also came up with a few new loss terms for smooth interpolation in this specific task. As shown at the bottom, case 1 is an ideal case where the stroke grows smoothly. Case 2 and case 3 are counterexamples. In case 2, a stroke overgrows and then shrinks. In case 3, a stroke grows in fragments. The interpolation loss uses the sum of VGG output from different layers to encourage smooth and linear transition. The strokeness loss uses the square root of a Gaussian blurred version to penalize fragmented segments. This is based on our observation that Gaussian smoothing produces more non-zero pixels when the pixels from the input image is more separate from each other. Our design of these two new loss terms will make the network prefer the ideal case 1. Since the network is trained on synthetic line drawings, we cannot expect it to perform very well on user-created drawings, because it hasn't seen those styles before. To make it generalize from NPR to actual drawings, we use an optimization-based method to get the input drawing embedding. As shown at the bottom left, the initial reconstruction from Z0 is quite different from user input. We optimize the latent vector Z with all the weights frozen in the trained network, so the drawing reconstruction from the optimized latent vector Z star can be very close to the target. Now, I'm going to show some results of style transfer to another frame. Here, if we input a drawing with a particular style at any frame, the output would be very close to the target. The girl on the left uses a suggestive contour style, and the mouse on the right uses a canny edges style. We then show how it can interpolate between two user-edited drawings on a static frame. We can see our interpolation results in the top row, where strokes appear and elongate smoothly. In contrast, the baseline interpolation using a vanilla GAN failed to generate a meaningful interpolation. Here we can see the animated result for the girl character. And we can see this animation again. Similarly, our method interpolates smoothly on the mouse character, whereas the baseline interpolation using a vanilla GAN failed again. Here we can see the animated results for the mouse character. And we can see this animation again. Finally, we show how our method can support an interactive editing workflow for a dynamic sequence. Here, the user only creates one keyframe drawing, and their style of simple contours is automatically propagated to all other frames. Here we can see the animated results. And we can see this animation again. If the user creates another keyframe drawing with a different style, say with all the folds on the skirt, our method can interpolate between these two styles in the in-between frames. Here is the updated animation. And we can see this animation again. The user can create a new drawing if not satisfied, and the drawings will be automatically updated. And here is the new animation after this change. And we can see this animation again. Finally, the user can also remove a keyframe drawing to relax the constraint, and we can see the frames at the beginning are also updated. Here is the final animation after these iterations. And we can see the final animation again. In conclusion, we propose a deep learning-based method for interactive line drawing synthesis from animated 3D models. The learned style space is disentangled from the underlying geometry, enabling smooth style interpolation on static and dynamic frames. This is an effort in user-centric algorithm design, which helps us move closer to the best of both worlds, that is user-controlled synthesis. Some limitations of our work include being character-specific. Our method can generalize by fine-tuning a model trained on a character using data from another character, and it can reduce the training time from 48 hours to about 15 minutes. But there is still work to be done on generalization. Some synthesized frames have a limited quality, especially for strokes on a character's face. This may be handled in the future by including more training data through sampling more NPR parameters and using more NPR methods, so we can expand the style space more descriptive of actual drawings. Learning with a vector representation and factoring in dynamics in drawing are also very interesting directions. And this is the end of my talk. and look forward to any questions you may have. Thank you.